Hello, my name is Andrei Yukov, and as for my preparation to the data analytics exam, uh, I'd like to show you one interesting tutorial. So there is a part of services concerning Internet of Things. So it's the base for one of the base to the data analytics, because we have to get data to analyze it then. And here is the IoT core where we can find a small tutorial that explains the main idea of IoT. So let's start it. So here it is, IoT, learn and tutorial. So what do we have? We have a device gateway that connects, that receives some data from devices like for example, smart home or some devices in a medical organization, and etc. There are hundreds of examples of IoT devices. So the device gateway enables devices to securely and efficiently communicate with AWS IoT. Here are the protocols that's supported by IoT TLS. Yes, TLS protocols, MQTT over WebSocket, MQTT, HTTPS. And there is a difference between, of course, there is a difference because between MQTT and HTTPS. So here are they publish and subscribe, and only publish here. Device SDK supports MQTT and uses protocols. No SDK support, but you can use language-specific methods to make HTTP requests. Okay. Now, quality of service levels 0 and 1. Here, QoS is supported by passing a query string parameter where the value can be 0 or 1. You can add this query string to publish a message with the QoS value you want. So MQTT can receive messages by missing while device was offline. HTTPS cannot do this. Good function. Client ID field support, yes, no. Device disconnection detection, yes, no. Secure communications, yes, both of them. Topic definitions, application defined, yes. Message data format, application defined, and protocol overhead, lower higher, power consumption, lower higher. Here are some connection duration by authentication feature, 1-2 weeks. Oh, very interesting. Okay, let's go further. So things can communicate with each other via the device gateway, even if they are using different protocols. Very important. So we have a connected light bulb here and a control unit both connected to the device gateway. The control unit can publish commands into the device gateway, and the light bulb can subscribe and listen for relevant commands. Okay, very funny tutorial. So let's go next. Uh, then we have to process and act on data with the rules engine. The rules engine evaluates inbound messages published into AWS IoT, transforms and delivers them to another thing or a cloud based on business rules you define. Here, here is more information about rules. It's a whole list. Rules give you device the ability to interact with AWS services. Yes. Augment or filtered data received from a device. Write data received from a device to an Amazon DynamoDB database. Save a file to Amazon S3. Send a push notification to all users via SNS. Publish data to an Amazon SQS queue. Invoke a Lambda function to extract data. Process messages from a large number of devices using Amazon Kinesis. Send data to the Amazon Open Search Service. Capture CloudWatch metric and CloudWatch alarm. Send the data from an MQTT message to Amazon Machine Learning to make predictions based on an Amazon ML model. Very important thing for me now. Send a message to a Salesforce IT input stream. Send message data to an AWS IoT analytics channel. Start execution of a step function state machine. Send message data to an IoT events input and send message data an asset property in IoT sitewise and to a web application or service. Various possibilities, and so let's continue the tutorial. So the example illustrates a rule that evaluates commands published by the control unit. So if we send B in blue, then it transfers to green. Red is red, green is green, and blue is green. And if we switch it off, then blue will be blue. Wonderful. Let's continue. So, rule actions. The rules engine can also route messages to cloud endpoints such as Lambda functions or a DynamoDB table. So here are the actions that can be triggered. Very interesting. Not all the services are available in all the regions. So we can make rule actions to Kafka, CloudWatch, DynamoDB, Elasticsearch, HTTP, IoT analytics events, and sitewise. What is it? I yet don't know. Okay, Kinesis, Lambda, OpenSearch, republish. Yes, okay. Republish is a message to another MQTT topic. Fine. S3, Salesforce, IoT, SNS, SQS, step functions, and time stream. So, okay, let's go. Here we have a rule. Here, this rule sends data to these services, and this is our previous rule. So if we get red, it goes everywhere. If we send green, it goes to our device and to this device. and blue is becomes green if we switch it off. So we like a game. Okay, so the rule delivers copies of the message. It's important to three endpoints. Mhm. Okay, so as for the copies, in Kinesis Firehose, you can get data only once, and from Kinesis streams, you can get data uh, as many times as you want during some period. It's important also. So here, what we have a device shadow. Uh, AWS IoT includes device registry and device shadows. So you can register anything you wish to represent in the cloud with a name, some attributes, and a persistent virtual shadow. The example at the left shows that a thing has been created to represent the physical light bulb with a virtual counterpart in the cloud. Try turning off. Okay. What is the meaning of this shadow? So, for example, if we have a device and it is switched off from the network because of some accident, the information will come to the shadow and device, and after the reconnection to this main device, this information will be sent to it, as far as I understand. So here, uh, what if we, yes, and if we send blue, we shall, we shall get okay in all devices and services. So next, and the last feature is build solution. So we can read and set device state with device shadows. So AWS IoT makes it easy to build companion applications that interact with our connected things. So here is a mobile application that reflects the color of your light bulb. The mobile app yes, the mobile app never communicates directly to the light bulb, or rather the mobile app uses a REST API to read and set the state of the bulb's device shadow. So it it works in this way. Very interesting. So that's all for this video. I hope the next will be some lab more complex and difficult. Thank you very much. Bye.